Hello grade 9s, this is Mr. Miller, and welcome to lesson 3.4 on using exponents to solve problems. The first problem involving exponents is about volume. Question number 1, find the volume of a cube whose side length is 4 centimeters. So let me just draw this cube. Just do a rough 3D sketch. And with a cube, we know that the length and the width and the height are all the same, in this case 4 centimeters. So the volume, which is length times width times height, since all three are the same, that means we're effectively doing 4 cubed. 4 times 4 is 16, times 4 is 64, so it's 64 cubic centimeters. In the second example, we are looking at a colony of bacteria that triples every hour. Currently we have 30 bacteria. How many will there be after each amount of time? So, after 1 hour there will be 30 times 3, which is 90 bacteria. In 3 hours, that means that 1 hour has gone by and the population has tripled, another hour has gone by, the population has tripled, and a third hour has gone by and the population has tripled, which means that we've done 30 times 3 to the power of 3. Now the 3 to the power of 3 part of it is equal to 27. We multiply that by 30, we get 810 bacteria. So what you'll notice is that the exponent here is the number of hours. Just like the exponent here, although we didn't write it, it was 1 hour. And so that's what we're anticipating for part C. We can go straight to writing that this is 30 bacteria times 3 to the power of 12, because when 12 hours goes by, we will have tripled the population 12 times. And so the 3 to the power of 12 part is going to be a fairly large number, and so I'm going to have to do that on my calculator. 3 to the power of 12 is equal to 531,441. If I multiply that by 30, then I get a very large number. This is 15,943,230, and that's the number of bacteria. And generally speaking, if we know that the population is starting at 30 bacteria and we know that n hours has gone by, then that means we are going to triple the population n times. So that exponent is the number of hours gone by. Let's take a look at a third example of using exponents to solve problems. What is the surface area of a cube whose side length is 6 centimeters? Well, when we have a cube, again, we know the length and the width and the height are all the same. Again, I'm just doing a rough sketch here, so this is 6 centimeters by 6 centimeters by 6 centimeters, and the surface area is calculated by finding the area of the front face, which is a square, 6 by 6, and multiplying by 6 because there are 6 identical faces just like it. So 6 being the number of faces times 6 squared, the area of each face, that gives me 36 times 6, which will give me 216. And just as a double check, if I do 36 times 6, yeah, that's 216 square centimeters. And you might be saying, well, how come I didn't just do 6 cubed? I don't want to confuse that with volume, so just to distinguish this from a volume question, if I'd had, let's say, a smaller cube, that was maybe 2 centimeters by 2 centimeters by 2 centimeters. Okay, then its surface area is going to be 6 times, because again there are 6 faces that are identical, and each face is a square whose area is 2 squared. So this is 6 times 4 in this case, which gives you 24 square centimeters. Okay, so it just gives you an extra example to illustrate that. Next, question number 4, find the side length of the square attached to the hypotenuse in the diagram. Well, here we have a right triangle, and so we are looking at using the Pythagorean relation. In the Pythagorean relationship, we know that a squared plus b squared is equal to c squared, where c is the length of the hypotenuse. So I know that that is the hypotenuse because it's the one that's opposite to the right angle, and it's also the longest side in this triangle. So I can call 9 either a or b. In this case I've decided to call it a, and I've decided to call 12 b. So now what I'm going to do is I'm going to replace the a here with 9 centimeters, and I'm going to replace the b with 12 centimeters, and when I square each of these and add them together, it gives me c squared. Of course, I would like to know what c is. I need to know what the side length of that square is, and that's c. So to get c, I take the square root of 225, and that's 15 centimeters. In this 5th example, the diagram shows a circle that's inscribed inside a square, and the square has a side length of 16 centimeters. We want to know what is the area of the shaded region. We're going to give our answer to the nearest hundredth of a square centimeter. So this shaded area is equal to the area of the square minus the area of the circle. The square is 16 squared for area. The area of the circle is pi times r squared, but what is the radius? Well, you can see here that the diameter is equal to 16 centimeters. That means the radius is 8. So 16 squared is 256, and we're subtracting 64 times pi. So 8 squared is 64. The rest I'm going to do on my calculator, and 256 minus 64 pi is equal to 54.94 centimeters squared. Now, if that type of question you're getting a different answer from what you have in the back of the book, then I would suggest use 3.14, because the textbook may use that as opposed to the pi button on your calculator. Next question, number 6. The combination for one type of bike lock has 4 numbers from 0 to 9. The smallest combination possible is 0000. The largest is 9999. How many combinations are possible? Well, with these 10 different digits, we can have 10 different digits in the first spot, 10 different digits in the second, 10 different digits in the third, and 10 different digits in the fourth spot, which gives you 10 to the 4 as a power. Calculate that answer, it's 10,000. Number 7, in the formula d equals 4.9t squared, d is the total distance in meters and t is the time in seconds that a skydiver free falls. We want to calculate the distance that a skydiver falls in the following times. So in 2 seconds, we're going to fall a distance of 4.9 times 2 squared in 4 seconds, they're going to fall 4.9 times 4 squared. So this is 4.9 times 4 in part A, and 4.9 times 16 in part B. 4.9 times 4 is equal to 19.6 meters. And in part B, we have 4.9 times 16, which is 78.4 meters. And last example here of using exponents to solve problems. A cylinder has a radius of 7 centimeters and a height of 12 centimeters. We want to calculate its surface area. So you probably already know how to do this from Math 8, but just in case you forget, a cylinder has a circle on the top, it has a circle on the bottom, and the lateral faces are is a rectangle. I'm just going to connect this all together, make it look like a cylinder. Okay. And there we go. Just going to erase this edge here. And there we go. So, in a cylinder, usually you're given the radius and you're given the height. Now, if we were to unwrap this this cylinder and take a look at it, you would find that you've got a rectangle and you've got a circle on the top and on the bottom. Okay, so the circles are pi r squared each for their area. The rectangle, of course, we know that the width here is the height of the cylinder, but how long is it? That's the question. Well, this length has to be long enough so that this length has to be able to wrap around the can. Right? So that means it has to have, it has to be equal to the circumference of the circle. The circumference of a circle is 2 pi r, and we're multiplying by height. That will give you the area. So total surface area is 2 pi r squared for the two circles, 2 pi rh for the rectangle. And now I can plug in the numbers that I know. I know that the radius is 7, and I know that the height is 12, and now I can work this out. So I know this is 49 times 2 pi. I know this is 84 times 2 pi. And so here we have 98 pi and another 168 pi for a total of 266 pi, and when I calculate that to two decimal places, 266 times pi, that's equal to 835.66 centimeters squared. Of course, if you'd rather just do the whole thing one step, you can certainly do that. Do 2 times pi times 7 squared plus 2 times pi times 7 times 12, and it'll give you the same answer. So that's it, and thank you for watching the video.